Hi, Thomas Wally here. Currently enrolled in the Nicholls State University um, petroleum program. This particular class is petroleum computational methods. Um, Module 6 assignment is to uh, utilize geometry skills to effectively calculate how many barrels is in a cylindrical tank. Having offshore experience, we deal with many of these type of tanks coming out to our rig all the time, and to be honest, most of the time they come with good labels and correctly indicate how many barrels they can hold. Well, say that were not the case and we do not have any correct information coming out with the tank and we know how many barrels we need to safely put in it. We can do this by using its dimensions, taking in its dimensions manually, and using our formulas that are in this chapter to accurately figure out how many barrels we can safely put in this tank. Showing the work over here, I've got the tank sketched out in a diagram, and I've got it broke down into three different sections, A, B, and C, which I think was easier for me to separate it into three sections and just calculate out each section and add them all together at the end to get my final answer. Okay, so the first thing you'll notice in section A is it's a complete mirror image of section C. They both have the same dimensions. I still went ahead and divided them just so it'd be easier at the end to keep track of all of them. Okay, so the dimensions on section A is from center point to the outside is 7 foot, and from the outside to the middle, which would be the radius, is 7 foot also. Same goes for section C. So we use our equation for taking the volume of a sphere, which is right here, and since I'm only getting half of it, I put multiplied times by 1/2 at the end, just so it give me an accurate number for just what half of the sphere is. Okay, so we know our radius is 7 foot, so you just plug 7 foot into the equation, and it's 4/3 times pi times 7 cubed. Okay, I went ahead and simplified 7 cubed and brought it down to the next step. You multiply 4/3 times pi times 343. That gives you an answer, times 1/2, and that led me to 718.4 cubic feet. Okay, and that is just in section A, so we have that here. Moving on to section B, we use the formula that is given to accurately find the volume of a cylindrical tank. There again, we have the measurement all the way across the tank. The diameter is 14 foot. So half of that would be our radius, just the same as in what's in A. And these are two equations that we use to find the volume of a cylindrical tank. So V equals pi times radius squared times the height. The height would be the length of where the curvature of the sphere stops and where it starts again for the other side of the tank. That's 28 foot. That's given information. So we plug that all in. Pi times 7 squared times 28 feet. Simplify the 7 squared into 49. Pi times 49 times 28 gives us 4,310.3 cubic feet. Okay, so I have A, I have B, and since C shares the same dimensions, this is essentially the other part of the sphere. So I just took the exact same product that I ended up with A, moved it down to C. So then I got A plus B plus C equals total. So 718.4 plus the 4310.3 plus the 718.4 from C gives me a total of 5,747.1 cubic feet. Okay, then from our conversion, we know that there's 5.61 cubic feet in one barrel. The answer we're looking for is in barrels. So we take our 5,747.1 cubic feet and we divide that by 5.61 cubic feet, which is a barrel, and that leads us to 1,024.4 barrels that can be totally held in this cylindrical tank.